Good morning. We are here live in Morrisville, North Carolina at Weinig Holz-Her USA. My name is Andy Turner, and I would like to welcome you to day 2 of the Retool Tour. If you've been watching us, if you watched anything yesterday, you know that we are streaming live on Facebook, we are on YouTube, and we are streaming live at weinigholzer.com. So again, that's weinigholzer.com. Join us today. We're going to be going on doing this all day. There is a schedule of events that will be at weinigholzer.com if you want to pick out the times that you're going to watch. But be with us, stay with us, share it, like it, all those sorts of things. First thing we're going to start off with this morning is we're going to talk a little bit about making passage doors using a ProMaster from Holz-Her and the Easy Stop from Weinig. So I'm going to introduce a couple of people to you that are going to take it from me. Bring in Mr. Daniel Dew. Nathan, you going to be a part of this too? All right, Mr. Daniel Dew and Nathan Gower, some of our applications guys here at Weinig Holz-Her US, and I'm going to turn it over to them. Daniel, thank you very much for helping us out.
Thank you. Again, my name is Daniel Dew, and this is Nathan Gower, and we're from the applications group here at Weinig. One of the things we're going to talk about today is how to make a passage door and potentially what are the advantages to certain methodologies of how to make a door. So if you just come with me over here, I've got a door, and we'll just sort of go through the steps that are required in order to actually make a high-end passage door. So you can see here we have a louvered door. Now, from our vantage point, whether it's a louvered door or a center panel or a glass insert door, it makes no difference. It makes no difference. It's just a machining difference, right? Just you send different code to the router, right? And so in this case, we're doing a mortise tenon haunch joint with a profile, and that way assembly is very easy. It's basically slot A, fold B construction. On the door also, on the router, we're going to do our custom hinging. And also we can do our lock set that's specific to each type of hardware that you'd have, right? So if you have one style of hinge versus another style of hinge, the router is just going to take that into the idea and just machine it differently. All of these machinings can be programmed with EnVision, right? So now not only can I make custom doors as far as operationally what they are, but now we can add parametric sizing and positioning. So I could make this door 102 inches tall, I can make it 60 inches tall, and it's not going to matter. Whatever the customer wants to buy, right, as it's ordered, the machining is going to be made dynamically to the router. And with the 5-axis router, we can do all of these joints in one operation. Right, again, if you were to look at this, right, typically you'd have a profile or run it through a molder or a shaper, you'd have a hinge machine, you'd have a lock set machine for the opposing side, and then you might also have a dedicated mortise tenon haunch machine, or you would just do stick and cope. But with this right here, we can do all of the high-end operations on one machine in one step. So the part only goes to one station once it's cut and identified, and it's instantly coming off that machine is ready for assembly. Right. Again, right, because we're parametric, if you wanted to offer a louvered door, and this is just an example of something different that we can do, right, the gaps in the louvers are programmed in, and the software will calculate how many louvers you're going to need, add that to the bill of material, right, and then do all of the machining with appropriate spacing so the louvers fit in here right. Right, that's atypical for passage doors. And again, you have the custom machining on the lock set, so you can cut all your pieces, label them, take them to the router, and load 4 or 5 pieces on the router at once, so that way you optimize your tool changes, get all of these custom operations done on the door all at once, take it off the machine, and you're ready to assemble. Okay, so Nathan's going to take you through the import on the Easy Stop. Now, for time's sake, we've already cut and labeled some parts, and we're going to just take a part back over to the router and run it for you. So Nathan, you want to take and explain the interface of the Easy Stop, and we'll go get the board.
Sure.
Okay.
All right, let's do this. First step of the process. Good morning. So we're at the Easy Stop now. This is the first step in our process for the 5-axis machining of the passage doors here. So first thing we're going to do is come to the interface, right? So the operator is going to come into our millVision Pro tab, and they're going to select the species that they'd like, and they're just going to import that cut list at the saw, right? The great thing about the Easy Stop is the fact that we can do linear positioning as well as optimization of the panel, right? So what we've got here today, we've got engineered style material, but let's say this was solid wood and it had a knot or something, right? The Easy Stop has the ability to optimize around that knot with some operator interface, right? Okay. So as you can see here, we've already got some pieces that we've cut and labeled, and the label can be completely defined by the users in the office, right? So you can put any information on there that you need relative to your specific process, okay? Right? The best thing that this does for us is that everything is organized from the moment that it's cut, right? So I never have to lose this part, and I always know what machining goes with this component, right? So once we've cut it and identified it, we can then take it over to the ProMaster, and we can do some 5-axis machining.
All right, so now we're going to just meander back over to the router. And again, one of the beauties in doing things this way, if you use the metaphor of kitchen cabinetry, one of the things that really changed with nested-based routers, well, CNCs in general with sheet goods, is that the operators no longer needed to know what was happening. Right, you take the machines over the parts to the machines, you scan the barcode. The router knows what to do because that was all taken care of up front. We're doing the same thing here. We're taking all of the decisions away from the operators, right, and we're putting them up front in the order. So what we're going to do now is we're just going to take that barcode and we're going to scan it, and you can see that it loaded it onto the router, right? So you can determine the zone. For example, if you want to machine a whole door, we could put both styles on the left side of the machine and then all 3 rails on the right. That way you can run all 5 pieces at once, again, optimizing your tool changes. In this situation, we're just going to, for time's sake, we're just going to run a piece. So this is John Long. He's going to load the part. Yeah. That was not an invitation. All right, so you got to tap them down. Make sure the part's on there tight. Now you also notice with the Holz-Her system, we're not using clamps. We're depending completely on vacuum, which leaves a completely open surface, so you don't have to take into consideration whether the router is gonna, you don't have a vertical limit on the tools that you might collide with by running vacuum. So one of the other things to pay attention to with this as it runs is that we're going to use one tool. It's going to do all of the joint work. It's going to do all of the mortises, the 3.5-degree back bevel, and the hinges without a single tool change. Now, these joints are just set up in the software, so all I had to do when I designed this door was tell it what joint I want where, right, and how it interacts with the part. So I just defined where, like, the center rail intersects with the style, and then the joint is placed there. So now it did the mortise tenon haunch joint, and now it's actually doing the mortise internally, so it could accept the style, the rail or the center rail. Now, this is all custom machining that's occurring, and the operator didn't have to do anything. And again, just to reemphasize this, what we want is that you can load 4 or 5 pieces on the machine, and then you can walk away, let the machine run for 10, 15 minutes, and then when you come back, you've got a finished door. By the time that's happened, the guy on the chop saw has already cut and labeled the next part, so one Easy Stop can easily keep up with one router, and we can machine about, not counting just the framing parts, we can do about a door every 15 to 16 minutes. Completely custom. And if you wanted a different profile, that's just a tool call. So now it's going to finish up the joints, and then it's going to go around the back side, do the hinges and the 3-degree back bevel before it puts the profile in the front. Nathan, have any thoughts on what we're watching today?
Yeah, I mean, from my perspective, coming from manufacturing, I think it gives you so much power and flexibility that we've created doors in-house where we've mixed the louvers and the center panels, solid wood center panels, right? And that's not something that you could do on single point, single purpose machines. And with EnVision and the flexibility provided, you can do whatever your customers want. If they want something crazy like that, you have the flexibility now that you can do it.
Yeah, if you want to put a glass insert, that's just a different machining. If you want to put an arch top rail, if you want to make an one of those doors that has an arch over around the top of the door, right, for those new those higher end homes with those round top doors,
Yep.
this is basically just a different machining operation.
Yeah. Change the dimensions of your top rail and watch that the angle of the French miter joint once it shift with respect to it. It's amazing.
Yeah, it's a lot of fun to watch run. Typically, when we go to trade shows, people who make this for a living, they come in and when they see the ease of this, they tend to like it pretty well. So we've done all of the joint work, all of the hinges, and the 3-degree back bevel, and we're only now going to our first tool change. That's the real advantage of a 5-axis router versus trying to do this on a 2 or a 3, and the flexibility of machining you get with the 5-axis.
Yep.
Now, granted, we're not doing 5-axis interpretation to make this door. It's basically single plane on a tilt, right? And now we're putting that profile on the front. But we're taking advantage of the 5-axis to not have any aggregates. And that's an expense that typically, by the time you get all your aggregates, will override the cost of the 5th axis.
Well, and tooling is always a long-term expense. So, I mean, if you can eliminate buying aggregates every time you want to do a new process, right, just program it.
Yeah.
Spindle bend.
Yeah. In this situation, we would have probably had 2 or 3 aggregates just to get those angles right.
Yes.
Okay, so that's our part. So John's going to come get it. And so from point of order to door in hand, you just take your parts. And again, with the French miter stuff, it would just be slot A, fold B, a little bit of glue, a little bit of time, and you have your assembled door.
It should look exactly like what we showed him in the video.
For good reason. Right. All right, so you just have to knock the dust out of inside there. And then, I mean, for the most part, the only sand, because of that joint with the mortise tenon joint, right, all your surfaces are pretty much, and coming off the router, all your surfaces are going to line up, right? So the amount of assembly sanding you have to do is minimal, right? Because, I mean, you're going to have to sand it because you want to get your edges to be perfectly flush, right? But you could run your finger across it because everything's on the same plane, right? All we're doing is skimming the surface, so the amount of sanding you have to do is a lot less. So the after maintenance on the door that you have to do to get the door to a finished state is really minimal.
It's minimal. Yeah, which is great in manufacturing because it reduces the cost of your product. So,
and and all that stuff is just cost. There's no value add in adding a bunch of labor at the end.
yeah, customer doesn't pay for that extra labor.
Right. Okay, so I'm not sure if you have any closing statements because that's all right. Well, I appreciate your time. Welcome to the Retool Tuesday. So you guys have a good time, and you'll be seeing me and Nathan a little bit more